Good morning, fellow scholars and future teachers. I made you a video last night, but I posted the link when it was at 95% finished uploading on YouTube, and then it never finished uploading. So I'm making you a new one. I am going to just briefly go over your week 3 presentation lesson of how you might do this using presentation software and Excel. I teach Excel to the quantitative literacy courses. That's all we do. I make them an Excel video for every single assignment they have. So I'm going to now show you guys how to do this. Rather than showing you how to solve these problems algebraically, we're going to solve them graphically and be able to explain what the graphs mean, because that's what you might end up using in an elementary school situation, especially if you understand it more. So let's go ahead and just get started here. For number 1, we're asked, and hopefully you guys have already read all of these instructions. I don't want to spend a whole lot of time talking about instructions, but we're going to solve 6 problems, and then you're going to make a PowerPoint presentation of these 6 problems, and then a Zoom video scrolling through the problems and talking about what you've done. And I'll get you a link to some examples from other scholars from last semester. All right, so for number 1, it says to draw a graph for some different things. And you guys did your homework already, so all of these should look familiar. They're straight out of the homework. When I go to the homework section and I click on any problem, I'm just showing you this real quick because some people don't know. Open any problem here and then go to question help. Oh, my little picture is covering it up over here. Go to question help and then print, and make sure you click print homework assignment, and then it'll load and the whole homework assignment will be able to print. I'm not actually going to do it because sometimes it takes a little while to load. So what I am going to do is I already have it open down here. All right, so this is what it looks like when it loads. You just literally get a printout of every homework problem. So there you have all of your homework. And it is number 6 that we're looking at. So number 6 is this homework problem asking us to identify different graphs. In the actual homework, some of the questions use the parabola and ask you to use it to identify a projectile motion, throwing an object. In our exam, it asks us to use this parabola to show the shadow of a flagpole throughout the day. And we'll talk about that in a minute. And then I have this graph that shows me a bouncing ball or a spring. It has different scenarios depending on, which homework problem you get. And if you think about a bouncing ball, starts at the bottom, and then, it has one high bounce and keeps going until the gravity makes it bounce less and less. So we would look at that graph, and you might think of the x-axis here as the time that's going by as the ball is bouncing, because time will increase. And then the range for the bounce is your vertical axis. So that's, the decrease in the range of the bouncing motion. And those are the little things you're going to explain on your presentation. And then you have floors going up on the elevator. So here you have the rise of the elevator, if you think about the y-axis as the floors rising. And then you can think of your x-axis as time going by. Because as the time goes by and the floors are rising, and you're going to talk about your graph. Now here we have gas in the gas tank. This is the one I'm actually going to do, because this is number 1 on your lesson here. It says show and explain a graph to correlate with the function of the amount of gas in a gas tank, when a driver refills the tank on a drive across the country. So in this, I'm going to open also a PowerPoint. Sorry, I thought I had that open. All right, so here I have my PowerPoint because I am going to create this. Sorry to do that. All right, my PowerPoint is open. I'm just going to go back to my homework. All right, now I'm zoomed all the way in on that homework. You guys might not have touch screen. If you want to zoom in, then you just do Control plus and it makes things bigger and smaller on your internet pages. So I'm going to grab this graph with my snipping tool, and everybody knows how to use a snipping tool because we did that in part 1. That's why in this class you have to do one assignment before you do the next. All right, so I'm just literally copy. I'm using my snippet tool, Control C, and then come back to my presentation, click on my PowerPoint and Control Victor. And I now have a nice graph in there. And you can get design ideas. I'm going to do this whole thing very basic. I just want you guys to kind of see what to do here and what to talk about. So here on this graph, I can insert some shape. Sorry. I'm going to insert text. And here I might put that my x-axis is the time, or no, let's say the distance in miles. And there's no problem, nothing on this thing, I don't know, I think, that it says whether it's miles or not. So you can say kilometers or, I don't know, it's racetrack season. What's the, about a horse running? That wouldn't make sense because horses don't need gasoline. But anyway, so here we have distance in miles on my x-axis. I'm going to copy and paste this, and then I am going to turn it vertical. Thank you for those of you in class. Remind me how to do that easily. So here, and if you guys don't know, if you double click on a word, it selects the word. If you triple click, it selects the whole sentence. And then I'm going to say this is going to be gallons of gas. I'm just naming my axes. And you know, you guys can make the font bigger and, you know, change it, make it colorful, make it look nice. And then what you might do in your presentation is you go to your draw. I have a pin here that I just got. I used it for the very first time last night when I was making this video for you guys. But this time, let's see if I can do it a little better. So the graph, I might explain that here is our starting place. Oh, and another thing from doing this video a second time is to make it bigger. I wanted to remember to make it bigger for you guys. So I have, and I don't even need a pin. I can do other things. I can insert a shape. Maybe I'll insert this little shape and I'll say, this is the starting place where this graph started. And I also couldn't figure out how to get a red pointer, so I could just use this shape too. The starting place of the vehicle when it was traveling 0 distance and how many gallons of gas it had in the tank. And then as the vehicle traveled, my X values increase, but my Y values decrease because I'm using gas. Then I fill up my tank. The tank gets filled up, one fill, but I didn't go anywhere. You see how I did not move forward, I only moved up because the gallons increased. And then as I traveled, the distance increases while the gallons of gas decrease. And that's the kind of thing you're going to talk about in your presentation. So that was pretty cool, actually, using that little symbol to drag along. I hadn't done that before. All right, so you can either make, for number 1 on this, you can either make it, you know, 4 different slides, 1 for each graph, or you can make it all 4 on 1 slide if you can keep it neat without being too busy. And just to point out real quick, on the instructions for this, it says, I'm just going to point this out here, to show your work with mathematical models and few words on your slides. So please remember that there should not be a bunch of words on your slides. Your words, you're going to write 5 sentences for each of these. And your words are going to go down here in your notes on your presentation. So I got that just down at the bottom below my slides. I just got this double arrow up and down and drug it up. And now I can put my notes, what you're going to say in here. So if you have all your graphs, all of number 1 on a single slide, then you would simply put all of your sentences on that 1 slide. Just do it how it makes sense to you. You have freedom to create this assignment partially, you know, on your own, as long as you have the minimal requirements. And also you can think about when you're giving your presentation, if you did want to have it all on one slide, then while you're doing your part of the presentation, you could always zoom in if you have a touch screen. So use the technology you have. I had a touch screen for a year and a half and never used it because I wasn't familiar with it. So experiment around with your new computers, make them worth the money. All right, now let's look at number two. Number two, whoa, that looks like a ton of algebra here. I know exactly how you feel. Because after teaching algebra for all those years, I know that when people see stuff like this, their brains shut down. So let's have a look at what this actually means. All I'm dealing with here is two linear functions. My first function is f of x. And you guys, well, let's go back to this PowerPoint here. I'm going to insert a slide. And I will just remind you guys of a couple of things very quickly here. Other things, always make sure you know how you can move your PowerPoint stuff around. Okay, so when you guys are looking at a function, all we're talking about here is something like, I'm not at the best angle to use this keyboard, but I don't think I can rest my hand on the computer. So if we have y equals, I don't know, 2x plus 3. This is just an equation. It's exactly the same thing if I say f of x equals 2x plus 3, where x can be any value. So if I say f of 0, excuse me, that means 2 times 0 plus 3, which is just 0 plus 3, which is 3. And this is a function. It just means that we plug in a value for x. Well, when we're talking about the function on our problem here, we actually have two functions. So let's have a look at those. I'm not going to do any more algebra here. I'm literally just going to do this in Excel, so follow along the best you can. And if you need to stop and rewind and listen again, then go ahead and do that. All right, so here on my Excel's tricky. If you want some more Excel videos, I have dozens and dozens of Excel videos, possibly 100 or more, and for the quantitative literacy courses. So if you really want to know how to use Excel well, you're welcome to, I'll give you guys that link to the lessons for that class. But in Excel, there's a lot of stuff tricky about clicking. For example, right now I'm in this cell, but I can't make it bigger. So I have to click out and then I can increase. So, but I can't spend an hour giving you guys Excel lessons. I'll just do my best to get you through what you need for your work. So I'm going to say that I have f of x, and I'm looking at the question over here, number 2, equals f of x equals 3x. If you can see where I just highlighted that over on your page. And you can even actually copy and paste that. So I just highlight this over on this page, Control Charlie, come over to my Excel, click inside of my cell, and Control Victor. And also, you know, you guys have had intro to computing. A lot of those quantitative literacy scholars have not had their freshmen. All right, so now I Control Victor that into, sorry, the screens are making you dizzy. All right, so I copied that right in there. So now I have these two functions. And I need an x column. So I'm just going to call this column x. So I have y equals 3x, remember, it's the same thing, and y equals, whoops, I guess I didn't copy that properly, but it was x plus 8. All right, now I have my two functions. So what I'm going to do here is I have that x equals what? Well, look over here at our worksheet. Oh, I have another thing I just also noticed is that here I have f of x. This needs to be called g of x. Because if you look back up here at the problem, I have f of x is equal to 3x. You can see this right here. And then I have that g of x is equal to x plus 8. All right. So now I see that I have, they want to know of all the stuff that it says in here, it says to solve for x equals 0, 1, 2, and 3. So that's all I'm going to put for my x values here, 0 and 1. And I could type in 2 and 3, but I like to show Excel, cool Excel stuff. So I'm just going to select these two cells, get to the bottom right-hand corner, little black cross, and drag it down. And I know most of you know this, but some of you don't. All right, so now it just wants to, we're going to just plug in this equation. Anytime I put an equal sign in Excel, it's now a calculator. So anything I do, like 6 plus 6, it'll do the math for me. Excel is now a calculator. So I want to know equals 3 times, and that's Shift 8, or the asterisk over on your number keypad, 3 times x. And here's my x over here on the left. So 3 times x, and then I press enter. Now, that's right, 3 times 0 is 0. So now I'm going to select this cell, just one click. If you double click, this won't work. One click, go to the bottom right-hand corner. Actually, I don't even know if that's true. Yeah, you have to only, if you do double click and you get back in there, once it's done math, the only way out is to press enter. Because watch what happens if I click on another cell. Well, sometimes it does, sometimes it doesn't. Just press enter if that happens. All right, one click, go to the bottom right-hand corner and double click. And it will fill in to the rest of that column, or you can also drag it down. All right, now what about g of x? Well, g of x is x plus 8. But here's the thing. I'm not just looking for g of x. X is something very specific. What is x in this particular function? I'm not just looking for g of x. I'm actually looking for what? What is x in this case? Well, it's f. I'm trying to cover that up with my hand so you guys can see. I'm trying to cover up all those g's with my hand just to show you that x is f of 0. Well, didn't we find f of 0? This, in my Excel, yours doesn't have to be exactly the same. Mine is Bravo 4. You see right here? Bravo 4 is f of 0, that cell right here. And then my next cell, Bravo 5, is f of 1, f of 2, f of 3, and that's what I'm plugging in for my g function. So right here where it says x on my g of x, this is actually f, of x. So now everywhere that I have an x in my g of x, that x is now f of x. And it sounds simple to me saying it because I understand it, and I understand that you may not understand. But what I'm going to do now is we're going to just plug in, we're going to plug in the f of x value there. So we could even put this right here, right? Just to show you. I'm going to extend my column, so I'm going to select my Charlie column and then go up here and just drag it out a little just to make it show nicely. All right, so let's see what we have. This all looks very confusing. I hope you can understand. If you don't, there are YouTube videos and your homework builds up to all of this. You know, this is next week's assignment. So once you finish all your homework, this should make more sense. So we have equals this value, whatever's in this column for f of x, this value, plus 8. That's my formula. I click enter, and then I get the bottom right-hand corner for this cell that I put my formula in, and double click. And now I get all of my functions. All right, well, let's do something else cool here, because in your presentation on PowerPoint, you're required to have graphs and visual representations of these functions. So now I'm showing the chart. Let's go ahead and let's highlight these up here. when I go to my home, click on home up here, and then you can start painting things different colors. I'm just gonna paint these like a light blue. And then I'm going to, let me make this bigger. So I'm just gonna do some cool little Excel things. Many of you may already know how to do. So I highlighted these cells, painted them blue with my paint can up here. Now I'm just going to select all of these cells, go to my borders, if you see where this is, where my mouse is up the top. And then on my borders, I'm gonna go all the way down to line style, and then to the very bottom and get the thickest black line just so it's very visual. And then I go back to my borders and click all borders. And now I get a nice thick border there. All right, and you guys can choose to color, maybe you want to color each of these columns a different color. I'm leaving much of this up to you. Now select all of these columns and rows, and then insert. I actually just thought of something I want to do. Now that I have these selected, I'm going to have to do something later, and I don't want it all the way squished against this alpha left portion. So now that I have these selected, I'm going to get this weather vane cursor and move it over just somewhere, which means that now I have to increase the width of my echo column. No big deal. All right, and you know, it's just aesthetics are important. Just making my Charlie column more narrow it doesn't even really matter. All right, so I'm going to select all of these and then insert. Oops. Insert a graph. Now here I have put tick marks on my graphs. And you have options. When you insert your graph, you have options for changing the colors. You know, you could, that looks kind of cool. Because remember that you guys do want this to look nice. It's for your presentation. So let's say I'm going to use this graph. And you know, there are others. Maybe like something different. So whatever you choose, now you can literally show, okay, this blue line is f of x and the orange line is g of f of x. And when I plug the value for f of x into the g of f of x function, it increases by 8. Isn't that what the function says? It says f of x plus 8. So that means that my y value, which is f of x is your y value. Remember when I said over here in this presentation, in this PowerPoint, y equals something is the same thing as f of x equals. So when I'm looking at this on my chart, I see that every time my y value increases by 8 when I plug in f of x. So that's a nice little visual here. And of course, you guys can use your pins and show how it increases by 8. For each one, find a nice lattice point. Here's one at 2. So here when f of x is 6, whoa, f of x is 6, then g of f of x increases by 8 and becomes 14. So you can, you know, do a better job talking about those things. But once you get all that on there, then what you can do, and you can do your drawing also on PowerPoint. Trying to get those big dots off there. I guess I didn't realize that the going back also changes your size. Sorry, this is probably making you guys dizzy. Sorry. All right, so now I have this nice presentation set up in my Excel. So I am going to choose my snipping tool down here, and new, and then snip. Control Charlie. And you know, if you guys know how to use Symbol Lab, some of you have a graphing calculator on your computer top, you are, of course, never limited just to the technology that I know how to use. I'm just showing you what I would do. All right, so now I'm Control Victor pasting this into my presentation. If you guys have some kind of cool background on your presentation, say yours looks like this, and you want your graph, it's kind of dark for what this is going to come up, but that's okay for now. Then you would double click your image, double click, go up here to color, and then set transparent color, and then whatever you click on will turn transparent. So that's very helpful for lots of presentations. It doesn't look great on this one because of the color isn't so fantastic, but you get the idea there. All right, so good. There's number 2. Let's move on to number 3. Number 3, we have 2 lines. I'm sorry, we're going to graph, show and explain the slopes of the lines. So let me show you guys what you can do on this one. I am going to create another chart because you see what we have there are 3 different lines. How many points do you need to graph a line? 2, because you just connect the dots. So let me show you what this might look like. We're going to have our x's and our y's because all functions have, well, when we're dealing with these linear functions, we have an x value and a y value. So here my x value, if you look over here at your chart, you can see that I have, instead of, they're calling it a point, and then the other point is q. So we have p and q are our 2 points. And we have x1, y1, x2, y2, where x1 is 3, y1 is 1. Remember, all points are named as x, y. And then our second point is 5, 5. So over here on my chart, I'm going to put in 3, 1, 3 for my x and 1 for my y. And then my second point is 5, 5. But I'm not going to skip. I'm just going to type in my 3, 4, I don't know what 4 is, and 5. All right, and you guys can do other stuff too. You can make this a nice color, make your chart look aesthetically pleasing. I'm just going to select these and insert a scatter plot, just a plain scatter plot. If you didn't see that, I just went to insert at the top of my Excel, insert, and then I went to the scatter plot and I just did 2 dots. Now, the lines are not working because I don't have enough information in there. I've only given it enough information to draw me 2 dots. So that's why that's happening. All right, so now I have those 2 dots there, and you guys can algebraically find the function. That's fine. You're welcome to do that. If you just watch the videos, it'll show you how, and even on my video, I show you how to find that written video I made you the other day for number 40 on your homework shows you how to find the equation of a line. So you guys can watch that if you want to do it algebraically. But once you get to this point, I know it just drives me crazy having a table without any borders or anything. And you guys could have left out the 4. I just wanted mine in order here. Once you have these dots, you can insert an illustration, a shape, and get a line. And now you can put your line here. Just draw yourself a line, and then you can move it around later. In your line, you can go up to shape outline, shape weight, and make it thicker. You can change the color. You can do all kinds of stuff with it. So once you have your line here, you would talk about that this is the line that goes between the 2 points. Now, what's the slope of this line? Well, the slope of this line is, we know, let's have a quick look here. I'm going to go to Google and ask Google for the formula for a slope of a line. And I hope you guys use this a lot. I always go to images because I like what I see in images. Now, if you guys want to talk about the formula for a slope of the line, you can grab an image here, put it over in your presentation. Copy and paste it in here. And now you can have this little thing to talk about your y minus y1, x minus x1 is your slope, where m is your slope. And you guys can get more information for your later problems off Google. So now to show the slope of a line, I might insert a right triangle. Some of you might remember that when we talk well, look at these other images. People often talk about slope as, I'm not a fan of this one, but you see where it says rise over run, or the change of y over the change of x. And we talked about all this in class. Actually, I like this little snipping a lot better than the last one I got. Kind of is more intuitive for what people know how to do. So let's look at the rise over the run in using a right triangle. So I'm going to insert an illustration, a shape, and go to right triangle. and just kind of draw one. I'm just going to draw one and then I'll move it around however I need to. So I'm going to put my right triangle to go from one point of my graph to the other. I'm going to actually just, wish I hadn't made this line quite so thick. Just going to decrease the width a little there so that I can see my lattice points. And a lattice point is 2 points that are where integers cross on your grid of your graph. In this case, 3, 1. And then the second point is 5, 5. So I'm going to put my right triangle on those 2 points. And get it to where it's actually on there. Because once I have my right triangle on there, now I can measure. You can put another line to show, and I am literally coming up with this as I go because this is not what I did last night, but it's a better idea than what I did last night. So that's the benefit of having to do it twice. So here I have this line, and I might, make it red or something. You guys would make it thicker. And I would show that this line is a measure of how many? 1, 2, 3, 4. It's a measure of 4. And, you guys can write, and this would be on your PowerPoint or on your Excel. You would write and then copy and paste later. So here I can say that I went up 4, and then I went to the right 2. So if I wanted to show with writing with my pen, or I can insert text boxes, I can say that I had a rise or a run or the change. We use a triangle in math to represent the word change. The change in y over the change in x was equal to a rise of 4 and a run of 2, which is equal to 2. So now I have a slope, and we can say all this is equal to m. We have a slope of 2 between those 2 points. And you guys can do this any way you want. If you find an easier way, better way, please. I learn so much from Math for Teachers. I love the Math for Teachers classes. There's no way I can teach as many classes as I teach and do what I do without you guys. You guys rock. All right, so let's look at the next one, and then you would do that with 2 more. All right, now number 4 is even easier because on number 4, I'm going to go ahead and create that 3 chart again. And as a matter of fact, you guys can recycle these charts. I'm just going to go up here, recycle this whole chart. Just paste it down here. Just because it had 3 things on it. And I'm doing, this one is parts Alpha, Bravo, Charlie, so. All right, so I've got this copied and pasted here. I'm going to widen my delta column because that's where that long one ended up. I don't know if I'll still need it long or not. It doesn't matter. All right, so here I have my x values. I started at 0, but for this particular problem, I'm going to be exploring parabolas. And you guys would have already done all these homework problems, so you already have some knowledge built up on these, not just what I'm saying in this video. I'm going to go ahead and start this at a negative value. I'm going to go from -10 to 10 because that's what we normally find in a window. We'll see how it works out. We might decide to change it. So -10, -9. Make this bigger so you guys can see it. I just went into my graph here. Sorry. All right, and I typed in -10, -9, and now I want to take this all the way to 10, from -10 to 10 on my my x-axis. So I'm going to select those 2, go to my bottom right corner of the bottom one, and drag it all the way down until I see the number 10. And if you guys can see that little number changing at the bottom right corner of my selected area. So there's 10. All right. Now, what is my first function over there? I think it was just x squared, wasn't it? All right, so I have my x values, and they call it y, but could I leave it f of x? Sure, it's exactly the same, just turns it into a function. So this is y equals x squared. So I just put that squared in there, and then I'm going to do the same thing here. Well, Excel, when I copied and pasted that chart from up above there and brought it back down, Excel kept I'm not trying to say proportion, I'm sorry. It kept the distance between the numbers. In the chart up there, it used the number to the left, so that's what it's doing down here too. So it already has my X selected. And if you didn't do that, then you simply select your left column, your X value, raise it to the power, that's Shift 6, your caret key, raise it to the power of 2. And then we are going to select this cell, and this time I'm just going to drag it all the way down, because I don't know if double clicking will get the whole thing. All right, so now if you just look, it just used the different X value for each cell as it moved down. That's what Excel does. It's cool like that. All right, now for this one, now I get to get rid of all this confusing stuff, right? I'm just going to call this one G of X. Even though your book just calls it Y, it's the same thing. Now it's a function. We're plugging in all different values, so it should be a function. And then this was what? X squared plus 7. So X squared plus 7. All right, now here I have X squared. And I mean, you know, really, I could do all kinds of stuff and just use this column because this is already X squared. And if you really looked at this, it is actually a composite function like what we just did. But I'm not going to do that. I'm going to do something different. I'm going to go ahead and make X be this X value over in the X column. So that's going to be X squared plus 7. Then I'm going to drag this all the way down. All right, super. I don't want to confuse you guys, but really this is just the same thing as we just did because this was f of x. X squared was f of x, so I know I typed this wrong up here, but it's correct in my formula. I forgot the 2 just on my notation, but the formula is correct. Okay, now we need the next function. What do you guys want to call it? I'm going to copy. I'm just going to select this entire column, Control Charlie, and then come over here and put it in and Control Victor. All right. Oh, this is going to be a kind of an ugly graph because of the size of these numbers. What's wrong here? Okay, here's what's wrong. I was thinking, wow, these numbers are way too big. Because my proximity, when I was trying to think of the word proportion earlier, it was proximity. The proximity for X here was to skip a cell. When I copied and pasted this, see how it skipped a cell to use X? So it kept the same proximity on the next one. So I have to go in and tell it to use this X value. Okay. Now, the problem here is that I did not change this. It should be -7. And also here should be -7. Okay? And then now I can just select this bottom corner and double click because it goes all the way down the whole chart. All right, that looks lovely. I am going to, darn, I meant to have this full screen. After last night's video, I thought, oh, I should have had that Excel full screen every chance I could. All right, now I am going to select all of these columns and rows and insert a graph. And I can have my graph with the tick marks. What is it called? Markers. With the markers or just the smooth lines. I'm just going to go with the smooth lines here because it's less busy. Just looks better. So my job for this particular problem is to explore these parabolas. Isn't this cool that you guys can do all of this graphically and use Excel rather than solving all the algebra? I think it's amazingly awesome. And try not to ramble. Okay, so in this graph, you know, you guys should add charts and titles. I didn't do that on the other ones I meant to. I did last night. But you just add this plus sign and you add axes, titles, and you can, you know, think of something and name them, even if it's just the function. This is your x-axis, this is your y-axis, and your title is Exploring Parabolas. And look, you guys want to see something really cool? What if I decided to do something else, like call this negative, or here? You guys can do this in your presentation. When you're doing your presentation, if you want to use a live Excel interaction, QL does it. You guys could do it too. If I change this to be a negative, I changed it and I was waiting for it to happen. But I have to change it in the formula here. So I'm going to make this negative, enter. And the reason that happened is because Excel wants me to put -1 times that. -1 times. So I don't know if you guys can see what I've done here, because I have it so small, but I put in -1 times my x value, just changing this to a negative function. That's what happened when only one value changed. I'm changing all of the values. And then you see how my parabola just turned upside down? And what if I said that -x squared plus 10? What would happen? Oh, I have to, that's funny. -x squared plus 10. I'm changing it into my notation and then expecting it to change. It just moved it up. So you guys can actually show different stuff and explore while you're doing this. It's pretty cool. Think of different ways to do things other than what I'm doing here. This is the risk you set as a teacher when you put out independent learning assignments and then you give examples. You sometimes only get back only what you showed instead of some cool creative stuff. So make sure you guys add your own creations to these. And then of course, you can keep this live on your Excel file, put it on a PowerPoint presentation, open different screens, be creative during your presentation. And then whatever you like best about what you did, you'll end up doing on your team presentation, because you're going to use all this same stuff in your team presentation next week after next. All right, what did we just do? Let's now look at number 5. We just looked at number 4. And number 4, we're looking for lines tangent. What does that mean? Well, it doesn't say lines perpendicular. Sorry, not tangent. I'm looking for one line perpendicular to another line through a certain point. Let's see what that looks like. I can show you actually on PowerPoint really quick. If I have it's always easier to revert back to drawing because that's what I know how to do. If I have a line, here's my graph, here's my line, and let's say that this is this is 6 and this is going to be -7. So I have a point right here, and I want to know the equation of the line that goes through this point, 6, -7, and is tangent to this other line, of which we could easily find the equation for, but let's not. Right now I'm just going to, okay, we have that y equals mx plus b, where m is our slope and b is our y-intercept. So if I wanted to just make up an equation to this other line right here, I could just call this, that's a 7, so let's call this -3, and then let's call this 2. So I can clearly see that I have a slope of up 3 to the right 2. So the equation of that line right there, that red line, is that y equals, what did we say, up 3 to the right 2, a change of y over the change of x, x minus 7, because b is always my y-intercept. Anyway, that's the equation of that line. So to find the line tangent, I'm sorry, I keep saying tangent, that's going to be number 6. To find the line perpendicular, which we also use the word orthogonal in mathematics, that means I'm finding the line that crosses that other line using an exact, 90-degree angle. So that means that this new line where they cross makes a 90-degree angle. That's what perpendicular means. Well, another cool thing is that a perpendicular slope, if this, man, I should have used some better colors. If line, let's call this line Mike, and we'll call this other one line Yankee. No, because that'll be Y. November. All right, so we have lines Mike and November. Line Mike has a slope of 3/2. We just discovered that over here, that the slope of line Mike, just write Mike here, has a slope of 3/2. Now we know that line November has a slope of the opposite reciprocal, because it is always the opposite reciprocal slope for a line perpendicular. So that means that Y November equals negative 2/3 x. We don't know yet the rest of it. We have to actually plug it into an equation to find the rest of this. And that equation is, and I do this in that other video, I don't want to do it all again, showing you how to find the equation of a line given a point and a slope. So you guys can watch that written video I did the other morning to find that, because today I'm not doing this. I just want to give you a quick lesson this way because that's what you're familiar with. You're familiar with the algebra. Forget about it for now, huh? Because for your presentation, I would prefer to see you use Excel. And let's see what that looks like. I have, first of all, this formula over here. I'm just going to copy and paste this. Control Charlie. Over here into my Excel, Control Victor. That didn't go so well. Might have been easier for me to, it's the fraction it didn't like. Just delete what you can and type in what you can. Make this bigger so you guys can see what I'm doing. My cut and paste didn't work so great. It didn't like the way the fraction was set up, so I just have to add that part in myself. All right, so this is just the notation portion of what I'm about to show you. And I'm going to make this, just widen this column a bit for aesthetic purposes. All right, and then, the other one, I didn't even realize you get to solve here. You do have to do a little algebra on the second part and solve this for y. Now, I'm not going to do this problem, but you would have to add 5 to both sides, subtract both sides by 9, and then divide everything by 2. Don't forget that college algebra is a prerequisite to this course, so those are algebra, beginning algebra manipulations there. All right, let's get back to this problem. So here we have our function. And then I'm going to have x values and y values. I'm just moving this over to the next cell and then widening it, only because visually I don't like to have things lined up in that alpha column for whatever reason. All right, so now I have my x column and I have my f of x column, or y, whichever. I'm going to paint them blue. My x's, I'm going to go ahead and go again from -10 to 10. I just like that. Select them and drag it down. And I'm going to drag it down all the way to 10. All right, now for this column, I'm actually just going to copy this. I don't have to type it in. And then right here where it has the x, uh-oh. All right, I didn't like that because I don't have things proper. And I was going to make it bigger so you guys can see. So to do that, I have to delete my equal sign. Because you can't get out of the cell once you put an equal sign in there. All right, so here, yikes, sorry. So right here in my cell, I'm going to go back and put my equal sign in. And I have -3/4 times x. Well, that's times x. That's Shift 8 for your asterisk, or use your number keypad, times x, which in this case is -10. I'm not even really sure if my negative is going to work. Sometimes Excel accepts that negative sign out there to the left of 3/4, and sometimes it makes me put a -1 times in parentheses like it did before, which is what it's going to do now. So And you know, the more you use Excel, the more you get to know it. But it's a hot commodity on your resume. And the folks who complete my quantitative literacy course can put proficient use of Excel when they finish the course, which is excellent for them and would be for you guys too. All right, so here I have my function, and then I'm just going to get that whole function and I'm going to graph it. Of course, I'm going to border, and I'm going a little faster because I've already done all this stuff on the other problems. So you can, you know, pause it, stop it, whatever. So I'm going to select this whole chart and insert a graph. And it's always just a scatter plot. I don't like those tick marks on it because, you know, it's just too busy. All right, so now I'm going to plot another point on this graph. I'm actually going to put another line here, and I'm just going to put y equals, or not even that. I'm just going to write, what did they call it in the problem? Sorry. Point R. You see here in number 5, it calls this point Romeo. So I'm just going to actually label this R. I actually did this different last night also. I used a lot more algebra last night, but then I, you know, thought about it as I was falling asleep that I was going to try to do it without all the algebra. So I know that this point is at 6, -1. So you see Romeo's at 6, -1. So I'm going to go down to where my x values are 6, and I'm going to put a -1 over here. Enter. And I actually should have done this previously, but I literally did not think of it until I was in the middle of doing that problem over there. All right, so I'm going to select all this and border. Cool. Now I'm just going to delete this graph that I already have here because I'm going to put this one in. Whoops. That might be where things go wrong. We'll see. All right, so I'm going to have to use the tick marks because when I just use the smooth lines, it does not capture that one point at 6, -1. So I have to use the tick marks on this one. I might be able to turn them off on the blue line and keep them on the orange line. You guys can explore that if you want to. So now I know that I need to have a point tangent to that line. Because I'm going to be dealing with a 90-degree angle, I would need to have a proportional distance between my markers on my axes. So you can see that your x-axis counts by 5s and your y-axis is counting by 2s. Because I have to use those tick marks, I'm going to have both axes count by 5 just to take away from the busyness of the graph. So I am going to, I double-clicked on my y-axis. And sometimes if you double click, it'll give you a chart or select the wrong thing. So just keep clicking until you get the axis. Once you do, this stuff pops up over here on the right, and yours might be default on Paintbrush. It could be on any of this stuff. To get the axis, you click on the graph, the bar graphs, and axis options. Now I have my axes options. Oh no, that's wrong. Tick marks, I think. Yes. Nope, that's all right, axes options. Okay, here, this is right. All right, so on your axes options, I'm on my Y, and you can see right here, it goes from -4 to 14. That's my, my range. Range is the Y-axis and domain is the X, sorry. I have this thing how I memorize it and it gets backwards in my mind. So here I go from -4 to 14 on my Y, but then look at my X. I go from -15 to 15. So I'm just trying to set my Y up to look like my X. So I'm gonna go ahead and go from -15 to 15 and then count by 5s, and it automatically did it for me. So that was kind of cool. Actually didn't know that it did that. So I'm done with that part. Now, they're still not proportional because look at my y-axis. Do you see the distance between the marks and then the difference between the distance and the marks on the x-axis? So be careful when you're selecting stuff. right now I want to just select this whole graph, and I'm going to drag it down because I want my y. That looks pretty good, doesn't it? Pretty square, maybe just a little more. So you want those to look like really, really good squares, and there are ways to make sure that they are, but this is good enough for now. Now, look at this line. I know that I want to build a tangent line that goes through this point. I could totally do that. Insert a line. Now, you guys can use your formula here, totally. If you want to just get the formula and put it in up here, you can. Like I said, I just thought of this. So I'm going to insert an illustration, shape, and line. Now, I'm going to draw that line. Well, in order for this line to truly be tangent, then I would need to, first of all, make certain that my my axes were proportional, that the x-axis and the y-axis had the exact same amount of distance there. So in this case, I am going to insert a square. Just thought of this too. If I insert a square, I can right-click on the square, go to my size and properties or format. I just always go to format. And then I click on this little thing on the right, and then size. And here you can see my square is not quite exactly square. So I'm just going to go ahead and make my square be 61 by 61. And now I can see that the height of, it's just not right. So I can simply move this in. Does it work like that? It does not work like that. I have to get this blue. I inserted my box in there. So Control X, get it out of the graph, and Control Victor. Now I can decrease the size of my chart a little. Put the box back in, check it. It's getting close. Keep checking it until it is in there. Sorry. All right, so that looks pretty good. It's pretty proportional. Maybe just one more little tiny bit. Now I can put this box anywhere in these lines and show that the thing is perpendicular by showing that it creates a 90-degree angle. Squares have a 90-degree angle. So now here I can show that this line is perpendicular, and I can even write the equation for my line easily by using my slope, right, and my y-intercept. But in this case, -10 is your y-intercept, it looks like, and then you would have to find a nice lattice point to calculate your slope. So it looks like we have a lattice point right here. I can actually just Control copy and paste this square, make it red. See if it works like that. All right, cool. All right, so I have a lattice point, it looks like right about here at 10, 5. And then another lattice point at, it looks like -10, I'm sorry, 0, -10. So what I can do here is I can count. From -10 to 5, that was a rise of 15. That was, whoops, draw. M equals a rise of 15 over a run of what? I rose from 10 to 5, -10 to 5 is 15, and then I ran 10 equals 10. I simplify that to be what? 3/2. All right. So let's see how close we got here. Did we actually solve this one? Oh, we made that one up, so we can't really say. Huh. Well, what was the slope on the one that we were doing? 3/4. So we are off. It should have been 3/4 for our slope. But we did this by using our graphs and explaining it. To do the algebra here, you guys would use your point slope formula. You may have to use the algebra. There may be a better way to do that on Excel, but at least you can see how you can explain it. To get the actual equation of the line, then you would simply do your formula where you have y minus y1 equals m times x minus x1, where in this case you had that y, your x and your y, x1, y1, were equal to 6, -1. 6, -1, so you have y minus -1, don't forget your negative in your formula, equals your slope. Well, your slope you knew was going to be the opposite reciprocal. So your slope here for your line was -3/4. So you knew your slope for this one over here was going to be positive 4/3, the opposite reciprocal, 4/3, times x minus x1, which is 6. All right, and then you have y plus 1 equals, you're distributing now, 4/3 times x minus 4/3 times -6/1 is -24/3. So now we get y plus 1 equals 4/3 x minus 8. Subtract 1 from both sides, we get y equals 4/3 x minus 9. So now we have the actual function you guys could have put into the graph here. Darn, I didn't memorize it. 4/3 x minus 9. 4/3 x minus 9. So all right. This will be cool. We can just see that everything we did looks right. All right, so 4/3 times x. All right, look at that. We were pretty close. That looks pretty good. You can see that blue line, or the orange line, is the line that they just graphed. And I didn't go all the way down. I could drag this to the bottom here. Whoa. My formula just didn't apply all the way through there. Now it is. All right, so our line was pretty close to what they got, and that's how you guys can show that it's perpendicular. And then you guys can still use the algebra. I was hoping you didn't have to, but I don't know how else to show you without doing the algebra. But it's still just algebra 1, so should be pretty easy. All right, let's move on to number 6. Now, number 6, this is what I came up with on number 6. We have to show the fact that we have a circle. Let me show you guys, and I did already draw all this out on that other written one that I had done, but when we're dealing, I'll just show you. Just to get you started explaining it here. I'm going to insert a circle because what we're looking for, I'm going to actually just start with inserting a square. I'm going to make sure that it's really a square over here. So I'm just going to make it 5 by 5. Simple. All right, so now I have a square, and I want my square to be, I don't want any fill. And then I'm going to insert 2 lines. I'm just copying that line. The square actually tells me where the centers are. And basically all I'm doing here is making myself a little graph just to show you guys something. You can do this too. Now I'm going to insert a circle. And you guys can do the same thing with your circle. Check the size of it. Here it's 3.2 by 3.36, so I'm just going to change this to a 2. And that's just the height and the width. All right, I'm actually getting my circle right. See how I have all my lines lined up? And then I can go to my fill. Well, actually, you have it right over here. You go to your fill, and you can make it transparent. Just kind of show that if you want to. All right, so now I am going to show a line tangent to this radius. And what it means is we want to know what is the line tangent to the radius that goes through the point. I guess I could use this one, it's already horizontal. Just copying and pasting a line to show you guys. Kind of make it a different color. Make it fatter, wider. So I'm looking for the line tangent to the radius at -9. So we're going to say that -9 is the line right down here, tangent to this circle. And that's basically the question. Tangent just means the line perpendicular to the radius that touches the circle at one point. So let's go back to our graph over here. And what I've chose to do here is I'm going to just name this XY. And you guys can actually graph a circle in Excel, and I Googled it, I watched a video on it, and I decided that's beyond what I want to do in this video. So we're just going to do this the easy way, the same way I did it last night. So my X values here, let's think about this circle. Let's get back over here. Remember, here I have a radius of 9, and the circle, it says somewhere on this problem that the circle, whose center, and it shouldn't say whose, it should say which or something. I don't think we use whose to refer to a circle, but I don't know. All right, and the center of the circle is at the origin. What is the origin? Well, that's what's over here on our center. The origin is always the middle of the graph. All right, so the dead center of that little graph that we created. And just like on this graph, the origin is right here in the dead center where the two axes intersect. All right, so I am going to look at this little drawing that I've created over here. Actually, I'm going to copy this little red thing I have on Excel and put it over here on my PowerPoint so I can use it to show you guys. So if the center of this circle is at 0, 0, and it has a radius of 9, that means that if I move up on the y-axis, that's +9. So that's the point 0, 9. And I can insert that into my, add a text here, and I can write 0, 9. Some parentheses on that. Whoops. All right, and I can, make it a different color, all kinds of stuff. So that is the point 0, 9. Well, if that's the point 0, 9, then this is the point what? 9, 0, right? Which makes this piece over here -9, 0, and this piece down here 0, -9. All right, so now I have all this on a presentation. That looks good, doesn't it? And look, when I'm talking on my presentation, I can actually move this dot around and talk about it. So do cool stuff like that. All right, so over here, back to my Excel. And really everything that I've just done there is all you really need instead of Excel. That looks pretty good, actually. But over here, what I did on this was I did these 4 points. I just named these 4 points. I had where X is 0, X is 9, and I'm just going around over here. What I'm doing on my PowerPoint is I'm starting at this 0, 9 point. Well, actually, I should actually start here. I'm going to actually change it. I'm going to start at -9 for my X, you see, and then I'm just going around in a circle. So I actually want to change this to be -9, 0, 0, 9, 0. And then my y values over there were the corresponding y values. Make sure you get the corresponding y values here. Number 0, 9, 0, and -9. All right, so I now have this little chart. You know how I have to do this, borders, drives me crazy. All right, so there we have that, and all I'm going to do is select this data and insert a graph of dots. You see there? But I have the same situation I had with that last one, is that I need my stuff to be proportional. So again, my axes are all messed up, so I'm going to select my y and count it by 5s, just like my x is. And then I am going to make this, and I'm not going to go through all of the major hassle of making absolute certain that those are squares. I'm just going to kind of eye it here. All right, so, and I can actually, duh, I have this, so cool. I can insert a circle. Well, actually, what could I do? I can actually just grab this circle I've already created out of my PowerPoint, bring it over here to my Excel. Make sure you don't paste something in there when all that stuff was selected. Did you see how all those things were selected on my screen? So just when you have stuff selected, you can't paste. You have to have it clear. So generically click off into the nothingness. All right, and then you can insert your circle. And I already know this is a perfect circle, but so I say but what I should be saying is, so now I know that's a perfect circle, so now I can correlate my graph to fit it. Cool, huh? I was way off, wasn't I? All right, so that's good enough. Now I want to show that line tangent. Oops. And if you look at the graph, it looks really good. It's supposed to be at -9, 9, and look how close it is to that 10. So this turned out beautiful, I think. But watch, this is a cool thing. If you know anything about graphing lines, then you would know that this line down here has a slope of 0. It's a horizontal line. It has a slope of 0. Again, that's Algebra 1, Foundations of College Math 1. So this line has a slope of 0, which makes it the case that y equals 0x minus 9, because that 9 is our y-intercept, which gives us that y equals 9. So in that case, no matter what my x value is, y is still equal to 9. So that means that this line down here is, what should we call this? Y, I don't know, we'll just call it, I don't know, Zulu. How about that? That's going to be, no matter what, I know, what do I say here? Y1? We'll just have y and y1. How about that? All right, so y1 is our tangent line, which, remember, and the reason I knew that it goes horizontal, this is an easy problem, because it doesn't have any slope. It's horizontal because it's perpendicular to the vertical line, so it has to be horizontal. And to graph y equals -9, that means all of the y values are going to be -9. So I can actually put this on my graph, select all of this. Wait, well, I can select this column, my X column, hold down my control button and select this Y1 column. And I'm only doing that because if I choose the center column, it's going to do a weird thing when I put my lines in. Well, darn. I guess it's only going to let me do it on a separate one, but you guys can see how it goes all the way right across down there. How do I do that all together? I'll show you why I can't. If I select all of this, then I would insert a graph. Well, I guess you still could, because see what happens when I put the lines? It tries to connect that circle in a weird way, and that's what I can't make that work. So, but if you just do the scatter plot, you could still do everything on one chart, just like we just did. I'll just do it for you real quick. All right, so here we did counted by fives. I'm actually just going to get rid of that other graph. I'm going to right-click this graph and send it to the back so that my circle will be in front of it. And then I'm going to do the same thing that I just did a second ago. Everything's always easier second time. All right, so now I have this circle here, and even though these orange dots are not connected, there may be a way to connect them. I'm not sure, but you can always just insert, well here, I have this line over here. Control, copy. Just make sure that stuff's not selected when you paste. I don't know where that went. I pasted it, the line. Get it again, just in case. Control copy. Sorry. I know it's disifying. Oh, there's the line. You see it down there? So now you can just put this line right over the top of those dots. And you can name stuff and color it and make it look nice. And then it asks you, the next part of this question is, does it have the same equation of a line if it intersects at 0, +9? Well, if I copy this, I can come up here and show, no, it does not. It's going to have the equation y equals +9. And then you guys can get fancy here. You want to talk about outside the box that's not even on here. You can choose to show the fact that the line tangent to the point 9, 0 is going to be that x equals +9. And then over here, x equals -9. So you guys can show all that using these presentations. I'm going to end this video. It's a way longer than I expected it to be. You guys are amazing. I appreciate all of your hard work, and I'm looking forward to seeing your presentations. Remember, everything you do for this assignment, you're going to use in the following week. You know, next week is this assignment, and then the following week, you're going to use all your favorite parts of this presentation to work together with a group to put together a team teach. So I'm super excited to see that, and I will be answering any questions you guys have. Feel free to text me. I'll talk to you later, or see you soon on Zoom. Have a good one. It's always awkward when you're trying to end these meetings. Bye, you guys. Keep being amazing. You rock.